This is an interesting question about trying to draw a circle on a chessboard that only goes through white squares or corners. So I think a good idea to start with is just to try and draw a circle. Like get a little sketch down. See, I've got a really accurate drawing here, and see if you can draw a circle. So what I did is I first of all thought, okay, I'm just going to go with this bit here, like the very corner of a white square to start it off with. But we can very quickly see just by symmetry that if we're going for, there's no way, if we're going through any white squares, we're going to go through exactly the same number of black squares. We can basically rule this out. Can't go through a corner like that. Now, it's also got to be by symmetry that you can't just put it in like a top left corner because then you're definitely going to get it going in some black squares there. I think we can rule that one out, which gives us two possibilities. We can either put it in the middle of a black square or the middle of a white square. And, just make the smallest one you can. And actually, we see that this one here works. That would be a possible circle. And then maybe try a different one. Okay, that one worked. But what about if I go to there? Okay, now this is problematic. So it worked for the small circle, but then we end up with it going through black squares as well. It's just how to prove that it's never gonna, no other one's possible. And finally, we've got middle of a white square. Can we make a bigger circle? Well, that's going through black, but what about this? Aha! Okay, this is possible. I've not quite got it in the middle, so it looks like it's going through that black square there. But I hope I can convince you. Okay, that's not bad. That, yeah, if we go that way, like this, we'll be okay. If we make it larger, let me just try with a, sorry, different circle, but with white at the center. Okay, then it's not, again, it doesn't seem to be possible. Yeah, so that one there. So these seem to be the two circles that work. It's just now showing that the bottom one is the largest one. So middle of black square to start with. Let's say we're going to put it here. Then it's got to be that it goes through like a corner here, for example. And then as it's coming around, it's got to go through here or something like that. Equivalently, we could say this point here and this point here as it arcs round. So we will require basically these 2 points to be the same distance away. So we will require a half squared, that's this x distance, plus n plus a half squared. In this case, n would be 2. This is my distance here. And that will have to equal, right, instead of going half along, I'm going to go 3/2 along. And then instead of going like n up, I'm just going to go n minus 1 up. So I'm going to go half up and then n minus 1 up. So it's going to be n minus 1 plus a half squared. So for the red dots, n would be 2. And for the green, it would be 4. Okay, and then we have to show that these are the same distance away for the circle to go through those 2 points. Because if they don't go through those 2 points, then it's going to end up going through some of the black square. So I hope that makes sense. I feel that is justified. Right, now let's figure out what n can equal. So we'll get a quarter plus n squared plus 2n. I'm multiplying out this double bracket plus a quarter. Now equal 9/4. Now actually this here is the same as n minus a half squared, so that's going to be easier to expand. 9/4 plus n squared minus n plus a quarter. So the quarters will cancel, the n squareds will cancel, and I'm going to be left with 3n equals 2. N will equal 2/3, so not an integer. So there's no solutions for this method. The one solution we do get is this special case here where it's not actually, it's only going through 1 point. So our special case is the only possibility. And actually, so the radius here would be 1/√2. Because I've got like a square and the diameter is all the way across. Because it's 1 by 1, it will be √2. So then it'll be √2/2, which is 1/√2. Maybe I'll just leave it as √2/2. Now, middle of white square. Same sort of argument. Okay, so now for this to work, we're going to have to sort of have it go through here. Actually, that one's, let's say, here, and then here. Okay, so it's going to be a half, and then some amount up, and then 3/2, and some amount minus 1 up. I think the diagram helps. Like, you could write this in words to fully explain what's going on. I'm hoping this is making sense. So we require half squared again, plus n plus a half squared. In this case, n would be 3, is equal to 3/2 squared from going 1.5 along, plus n minus 1 plus a half, or just n minus a half. Okay, expand these brackets out. These cancel, these cancel. I'm going to get 2n. This time is equal to 8/4, which is 2, and therefore n is equal to 1, which gives us actually our one solution here. Look, you can see in this special case, I go half along and 1.5 up, or I go 3/2 along and then half up. It works here, but that's the only situation where it's going to work and the circle is going to go through these 2 points, which it has to, like I said, for it to not go on any black. So that's my argument here. It has to go through these 2 points, not go on any black. So this gives our earlier example, and is the only solution, the only solution for this case. And therefore, the largest radius will equal, well, it's actually that half squared plus 1.5 squared, square rooted, which is actually going to give, well, actually, let me do it. It's going to be 10 over 4, which I can separate to root 10 over root 4, which is root 10 over 2. Okay, so hopefully you are convinced. I've argued using symmetry that it can't be on one of the corners. Um, I've said that it has to be, again, because of symmetry, it's got to then be in one of the middle of the squares. We've looked at the black square and shown that in general there's no solution except for this special case, which I wasn't included in the algebra that I did. And then I looked at the middle of the white square and I did a very similar argument and showed that it's only true when n is 1, which corresponds with our circle from before. And then we've got the radius. Okay, that is, I think that's a tough question to prove, if I'm honest. I think it's not too bad to get the circle by playing around with it. But how do we show that that is the largest one? That's the tough bit. So well done on your efforts. Have a look at the official solutions as well for how they did it. But I'm pretty happy with my explanation here.